next problem, we're going to look at something a little bit different, and that is absolute value and inequalities when they're put together. And this sort of problem is a very particular type of problem that comes up on the SAT, so I wanted to make sure that we definitely cover it. And I think that this will be really helpful if you have a problem like this come up, to just be able to solve it very systematically. So here we have that packets of jelly beans have between 84 and 96 jelly beans in them. We want to know which equation represents the possible amount of jelly beans in a given bag. So if I have just a bag of them, I can use this equation to figure out about what the range should be. And here, these problems, like I said, will come up and they'll give you some sort of range of what something has in it, or maybe how thick a given cylinder is. But there's a very specific range, and then we want to be able to use absolute value and inequalities in our equation to show what exactly is being represented. So here the thing is we take a variable, so here they used b all the way through. Obviously, when we're just making up our own variable, it doesn't really matter what it is. So if you were given something like this, you would just use whatever variable the SAT had already given you to use. So here we're using b for jelly beans, probably. And what we do is, inside the absolute value brackets, we take the variable minus the middle of the range. So we're going to figure out what that is by basically taking the exact average. So 84 plus 96 divided by 2. And that should be less than or equal to half of the range. And remember that the range is the difference between the smallest and the greatest number in our set. So here we're going to take 96, subtract 84 from it, and then do half of that range. In this case, we're going to get b is going to be less, b minus 90. The absolute value of that is going to be less than or equal to 6, because we basically have 12 over 2 here. And here we're going to end up with 180 over 2. So this is our equation. And if we look at it, we can see why exactly we want to do this and why this works. And that's because when we're solving, so inside the absolute value bracket, this could either be positive or negative. That becomes true for this part of the equation. So here we either have positive b minus 90 is going to be less than or equal to 6, or we have the negative of this quantity, so b minus 90 less than or equal to 6. In the case of the first one, I can basically add 90 to both sides. I solve an inequality basically like an equation. So here I get that b is less than or equal to 96. For this one, I have to multiply out the negative 1, so negative b plus 90 is less than or equal to 6. Here I can subtract 90 from both sides, and I'm going to get that negative b is less than or equal to negative 84. And then when I divide both sides by negative 1 to get just b, I'm going to have to flip the sign, so I get b is greater than or equal to 84. And when I look at this is in fact my two bounds. I have that b is between these two numbers. So putting it into this equation form is doing the same for me as saying that b is greater than or equal to 84, less than or equal to 96. And that's what I want in the end. So this does in fact work, and this is really the systematic way to do it, is to take it and do whatever our variable is. So here we had b, subtract it from, or subtract the middle of the range from it, take the absolute value of that quantity, and then make it less than or equal to half of the range. So look at this problem again. Make sure you understand it, and then any problem like this on the SAT, you'll be able to solve right away. And just get the answer right there. You don't have to resolve it out unless you really want to make sure that you checked it, and you can do that if you're coming back and have extra time. Otherwise, use this equation, get your answer, and move on to the next problem. That concludes our section on absolute value. Thank you again for watching Educator.com.